Swayam Prabha. Digital India. Educated India.
So, hello student, today we are starting the module 3 generation of solid waste. So, if you see, these are the 6 functional elements of municipal solid waste management, which I had discussed in the introduction and in the first lecture also. It separated in 6 functional elements which start from the waste generation to the disposal. So, I think the basic idea was that before starting the functional element, I talked about in previous lectures about different sources, types and also characteristics of solid waste. These are very important issue before starting the solid waste management and to understand the entire solid waste management system. In the previous class also I talked about the characterization of solid waste. So, most of our Indian schemes, policies are for the solid waste management do not discuss about the characterization of solid waste. So, if see in the Swachh Bharat mission also, most of the ULBs or urban bodies or corporations area, they purchase lot of compactor vehicle which can hold 7 to 8 tons of waste in a single trip compared to the 1 or 2 tons in the normal vehicle. But without understanding the characteristics, is very difficult to compact the such waste, because the 50 to 60% is a wet waste in the waste. Once you will compact that, lot of water, excess water or leachate is coming out, and because of that lot of corrosive issues are coming into such kind of compactor vehicle, which are very costly vehicles, which cost around 30 to 40 lakhs for a one particular vehicle. So, it's good, I think you properly understood about how important to understand the characteristics of the solid waste and also the sources and type of waste before starting the functional elements of municipal solid waste management. So, today we will discuss the waste generation. This is another very important issue because when you design any collection system or any disposal system, even the treatment system also need to understand the generation. In the previous lecture we already discussed about the type and sources of waste sources. Now, here we will talk about the waste generation and why it is very important to understand to know the generation rate or waste collection rate. So, in the first lecture in the generation, we will discuss about the estimation of solid waste quantity. When I say quantity, most of the people will understand the quantity means weight, but also the quantity can be measured in the volume also. And I'll discuss few issues about weight and volume both, where exactly the weight is important and where exactly the volume is more important. So, what is the importance of quantification is very important to determine the compliance with the central and state diversion program. See, most of the ULBs is not only discussing about the collection and disposal. Also, most of our policies or scheme also discussing about how we can diverse such waste to the disposal site for the purpose of recycling, for the purpose of treatment processes. So, very important to know the quantity of the solid waste to designing the waste collection routes. See here, the waste collection route also is very important to understand, to know the quantity of the solid waste. Not only route but also volume is very important, because based on that we can change the vehicle, what kind of vehicle, whether we will be able to compact such kind of waste, can you collect the waste from the compactor vehicle. To know the particular quantity, then only you can finalize the route, trips, how many vehicles, how many manpowers will be required. Also, for MRF facility or material recovery facility, whether it is a recycling facility or any biological treatment facility, quantity is very important to know about the manpower requirement or resource requirement, even the land requirement. For suppose for compost plant, if you are designing and if you do not know the quantity, it is very difficult to finalize how much is the land will be required for the composting facility. So, and similarly, especially for the disposal facility, the volume is very important to know that, and most of the cases you see in the city, wherever the disposal site is located, and within a few years, maybe 5-10 years, whatever the area is available in the landfill area, that is getting overed, and corporation always worried about to finalizing the new locations. Like most of the ULBs are worried about to finalize the new locations. So, the major problem because of that, because we are not aware about how much volume is receiving at the disposal site. So, these are very important for quantification, not only in the weight wise, also in the volume wise is very important to know that. So, again I think this graph is showing that, you see here the entire India, if you segregate in North India, East India, you see the recycling is only 17%. This is very important to know about the weight of the waste, how quantity of the waste, so that how much amount of waste is getting collected, getting disposed in the landfill, and how much amount of is getting recycled. So, you know, in the recent year the compositions of solid waste has been changing, and most of the recyclable matters like paper, plastic, these are coming into our solid waste disposal site. So, it is good to provide the recycling facilities, and also to know that how much is the efficiency of the particular MSW program. This efficiency, to know the efficiency of the particular waste management program is also very important to know that how much amount of waste is getting recycled, how much amount of waste is getting treated before it is reaching to the disposal site, and how best will be reduce the waste onto the disposal site, so that the small disposal site itself can work for the longer period. And also is very important to design the solid waste management facilities. So, like here you see in the one table, it is shown that how much amount of waste is produced in the different state of India, and how much is the collected and treated. Based on that we can analyze how much is the growth of the waste generation could be possible to know that, and also to know the efficiency of the particular city of waste management program. So, MSW generation estimated leads to evaluation of collection efficiency and treatment efficiency. This is also very important one when I say the collection efficiency. So, currently none of our city is able to have the collection efficiency 100%, means I think we are not able to collect the 100% of waste from the urban centers. So, to know that how best will be increase our collection efficiency, also the treatment efficiency is also important for the quantity analysis of the solid waste. Now, the quantification of solid waste in the both way, which I was talking in the early slide, that volume and weight measurement. So, both volume and weights are very important for the waste quantity measurement. But when you say the volume, the measured volume of waste must be either related to degree of compaction or specific weight of the waste under the condition of the storage. Now, I think there is the major problem to measure the volume, because there need to understand how much is the compaction, how best is the compaction is possible, because when the waste is coming to the disposal site, there also some kind of compaction is possible, maybe 20-30% compaction is possible, and if you are getting more amount of dry concentration, dry kind of waste is very easy to get compact very easily compared to the wet waste. So, the volume is always is a problematic to quantify the waste. So, it is better representation of solid waste generation is by the representation of solid waste quantity in terms of weight is more convenient. So, based on that weight is very easy. I think there no need to worry about the compaction. If you know the particular tons of waste is getting collected and getting disposed of, and it is very easy to analyze the weight also. So, there are some data showing the weight measurement of MSW quantification in India. In 2004 and 5, the quantity was 39,000 tons per day, in 2010-11 was 1,27,000 tons per day. Now currently India is generating around 65 million tons of waste per day with some of the data from the CPCB. And this generation in India by 2010-11 measure increased by 21.56% from the year of 2000. Means is a worried point. Now the generation, the increase are more than 20% in the every 10 years. So here if you see the state wise MSW generation, where Maharashtra is the highest waste generation, maybe because of, not only because of population, but is because of commercialization of the state and also the industrial development of the state. Now this is another very important discussion about the future prediction of the solid waste generation. This is also very important because if you just compare the data from every 10 years, the population is increasing by 5% increase, every annual increase of 5% population increase. Also the way our commercializations are increasing now, most of the city is getting commercialized now, and also number of industries are getting installed into the city area. So obviously there are a lot of waste is getting produced, getting generated. Now we are designing some kind of treatment facility, also need to run for longer period. If you design for 20 years or 30 years, so those kind of treatment facility or disposal facility is able to hold that kind of waste which is producing next 10 years or 20 years. So there is some data about the global data from Middle East or North American countries, like we will focus here the South Asia, where the by 2050 the waste generation will be second largest from the other continent of the earth, and only the East Asia and Pacific will be the highest one. Because why these kind of data is future prediction is coming by 2050, because not only the population is changing in the, especially in the South Asia and the East Asian countries, but also the lot of industrial growth are coming up now, and new kind of materials are coming to the urban areas, and more commercial facilities are increasing in such kind of countries. That is why the future prediction shows that especially the South Asian countries or Middle Eastern East Asian countries or specific countries will have highest waste generation globally. If you just see the Indian prediction here, and here very important data by 2051 MSW generation in million tons per day, and also the land requirement in square kilometer. You just see that currently in 2021 we required almost 400 square kilometer area for the land disposal, for the solid waste disposal facilities. By 2051 will be required 1500 square kilometer area for the waste disposal. Now is very important and very serious issue. By next 20 to 30 year will be required huge amount of land, and you know the India, the land availability is very important issue now in the, especially in the urban areas. So is very serious issue about waste generation and quantification of the waste generation. Now various expressions are for the waste generation rate. For residential, normally measured by kg per capita per day. Here capita is a person. So how much is the kg, or many places is writing like gram per person per day or kg per capita per day. For commercial waste also we will express the generation rate by kg per capita per day, and for industrial waste is expressed in the basis of measure of production. How much is the kg of waste is produced per production, and similarly with the agriculture waste also is expressed on the basis of measure of production like kg per raw product or raw material utilized for the production process. So, these are the different expression for the waste generation rate. So, here one data about few Asian countries where the data is segregated in large cities, medium cities and small towns. You see in the India where large city is only 0.5 kg per capita per day or just 500 gram per kg per capita per day, and compared to medium city and the small towns is only 100 gram. But if you see that the other country like Hong Kong 3.6 kg per capita per day, and see the Korea 2.8, Japan 1.2, these are all developed countries where generation rate is very high. But still India is not in the developing nations, our generation rate is still very low. And if you see the other countries like Nepal, Philippines, also the similar waste generation rate like India. But I think is a worried point because our urban centers are getting lot of commercial facilities are coming up now. Lot of industries are getting small scale industries are coming up now. So, lot of waste is getting generated in India in the larger cities also. This is another example of MSW per capita generation in different cities of India having different population. Now is a very surprising data. You just see the some data about Gangtok is a 0.42 or 0.43 kg per person per day or per capita per day waste generation, compared to the cities having population more than 20 lakhs like Chennai, Kolkata, Delhi is having 0.5 to 0.6 kg per person per day. This is not so very different data. I think now here the population is also very high, here population is less, but the data is almost similar, not much that difference. So, now is understand that the waste generation is not only because of population increase, but also the commercial facilities and daily utilization of the materials also is very important for the waste generation rate. Now, but if you just compare to the entire city, our waste generation rate is changing from 0.2 to 0.6, and most of the textbooks or most of the reports you see that India's waste generation rate is 0.4 to 0.6 normally is understand in kg per capita per day. Now, there are different ways to estimate the waste quantity. So, there is a first method is load count analysis. So, in this case the number of individual load or corresponding waste characteristics are noted over a specified time period. So, here is a very simple method. Every time when vehicle is entering to the disposal site, the weight is getting measured with the full vehicle and empty vehicle. So, that by that way we can analyze the how much quantity is getting entering to the disposal site. Similar way the volume method. So, if you have the special kind of vehicle and you know that what is the volume of that particular vehicle, you will be easily we can come up with the how much amount of volume is getting hauled into that particular vehicle. So, I will show you some of the photograph by that way. This is the one particular weighing platform where vehicle before entering to the disposal site is getting weighed in this particular platform with completely full vehicle, and with this is like one photograph, and also while coming back from the disposal site the empty weight also is getting measured. So, that we will come to know that how much quantity is coming to the disposal site. So, this is a very important discussion about by this method we can understand how much amount of waste is coming to the disposal site. We can say that I will not say this is a generation rate we can measured from this, but this is the collection, how much waste is getting collected, and there will be always discussion about the generation rate and collection rate, both are different. And in India, most of the report or most of the textbooks are writing like that whatever amount of waste is coming to the disposal site, that normally is understand by the to how much amount of quantity is getting produced in the city, but that is not completely true, because your collection efficiency was never 100%. So, it is very difficult to say that whatever waste is reaching to the disposal site, that is a total waste is getting generated in the city, that is not true. So, normally what we do for the to know that particular generation rate, from this method we will know the how much is the collection rate, how much is waste is getting collected. Normally some of the textbooks reported that the difference between generation rate and collection rate will be always 5 to 15% changes, and I think this we can easily resolve this issue if you know the collection efficiency of that particular city. If your collection efficiency is suppose 90%, and whatever waste is reaching to the disposal site, that won't be 100%. So, we can multiply this value by, or we can add that 10% which is not getting collected from the city by increasing that that amount 10% in the collection rate, that we can consider as an generation. How much is the generation? So, this point always has to be remember that whatever data is getting proposed, that whether is a generation data or collection rate. This another one more method, by that way we can analyze the quantity, that is material mass balance analysis. This is somewhat difficult for the city, but small commercial area or institutional area or industrial area, this method is very useful method. So, in this case we will come to know how much is the inflow of the material in that particular locality, particular industry or particular commercial areas, and how much is the outflow through the combustion gases or ashes, outflow in the form of solid waste or in the wastewater form, and finally outflow. By that way we can know that how much waste is getting generated in the particular locality, whether it is a commercial or industrial or institutional locality. There is one example for that. So, for that accumulation will be inflow minus outflow plus generation, that is the particular accumulation in that particular location. So, there is an example for mass balance in the landfill. So, how to calculate the waste placed into the landfill, that we can measure that mass leaving through the leachate. So, the leachate is getting produced. So, if you know that how much is the leachate is getting produced into the landfill site, that will include plus the mass leaving through the landfill gases, how much is the gases is produced, and how much is the waste remain, plus mass transport to the other product, whether is a maybe there will be some composting facility or some recycling facility into the dump site. So, finally, we will come to know that how much amount of waste is getting placed into the disposal site by this particular example, where we can come up with the mass balance of maybe methane gas or leachate production into the particular landfill site. So, these are the few methods, by that way we can quantify the waste. So, very important that to measure the quantity of solid waste, whether is a weight quantity or is a volume quantity. So, today we will finish this lecture here with the quantity. Next lecture we will talk about what are the different factors are affecting the waste generation rate, and those are very important factor to be understand that, and our always proposal will be that how best you will be able to reduce the waste or production of the waste or whatever the quantity is getting generated inside the municipal area. Thank you for today's lecture.